For this video, we'll be doing lesson 5-9, where we look at powers of products and quotients. So what we'll be doing is we will be looking at products, which is where we multiply, and quotients, which means divide. That kind of looks like a percent, doesn't it? Divide. Which will appear in the form of fractions, and we'll be using exponents with them. So we'll have to remember some of our previous exponent rules, as well as look at a few new ones. So when you have a product within the parentheses, so you have something being multiplied with something else, the power applies to both things. So in parentheses, 5 times 3, all of that to the power of 4 is the same as 5 to the power of 4 times 3 to the power of 4. So that exponent gets applied to both things that are being multiplied. In this variable example, they have a times b in the parentheses, all of that to the power of m. That means that this is really a to the m times b to the m, because again, that exponent applies to both things. When it comes to the quotient version of this, you're going to raise both the numerator and the denominator, to the power. So again, that exponent is going to apply to the top and to the bottom. So 2 over 3, all to the power of 4, is the same as 2 to the 4 over 3 to the 4. A over b, all to the power of m, is the same as, if m applies to the top and bottom, a to the m over b to the m. So when you are doing this, you're going to be applying that exponent to both of the products if they're being multiplied, or to both of the quotients if it's in a fraction form. Okay? The main exponent rule to remember, we're going to use our any-outy rule a lot. So remember, if there's one on the inside and outside, you multiply them. So like we would have like x to the 2 to the 3. That means that it's really x to the 2 times 3, which is really x to the 6. So this is from when we did those exponent rules. When we had an inside and an outside exponent, we multiplied them. So really it ended up being x to the 6. The reason for this will come in this first example. So make sure that you remember the rules for when there are any-outy parenthesis exponents. So this first one, we have two parts. We have 3 and we have z to the 5th. So that 4 is going to get applied to the 3 and to the z to the 5th. So 3 to the power of 4 times, on the inside of our parentheses is z to the 5th, and on the outside of our parentheses is a 4. The reason we put it in parentheses is because it already had an exponent while it was in here being part of the product, and we needed to apply another exponent to it. So see how we now have an example of an any-outy? This one isn't, but this one has an any and an outy exponent because there was one here, and then we applied the other one to it as well. So then to solve this, we still have 3 to the 4th, because we haven't done anything with that yet. And then z to the 5th on the inside, 4th on the outside. We're going to multiply those. So it's really z to the 5 times 4. 5 times 4 is 20. So we have 3 to the 4th times z to the 20. 3 to the 4th, 3 times 3 times 3 times 3 is going to give us 81. So we have 81z to the 20th as our answer. Okay. So again, that 4 gets applied to the first part, gets applied to the second part. 3 to the 4th, that's easy. Then we apply it to the z to the 5th. So we have z to the 5th on the inside, 4th on the outside. And then we solved down from that. So let's look at these quick checks. So when they write it like this, where it has two sets of parentheses, that's the same as having like a multiplier between them, right? When there's things in parentheses next to things, then they're being multiplied. So either way you write it, it's the same idea. So that means that we have two pieces, right? We have the 3 and we have the 2. So the 3 on the outside is going to need to go and apply to both things. So this is really the same as rewriting it as 2 to the 3rd times 3 to the 3rd. 2 to the 3rd, 2 times 2 times 2 is 8, times 3 to the 3rd, which is 3 times 3 times 3, which is 27. And then we get 216 when we actually multiply those. So step 1 is write it where you've applied that exponent to both things. Step 2 is show what those are. And then step 3 is what is the actual answer when you do that final multiplying. Okay, so we're going to pause. And you can do, let's do just B and then stop. So pause the video and do just B and then we'll go over it. Okay, so for B, hopefully what you noticed was that you have the 2 and you have the P. So those are the things that your 4 is being applied to. So you have 2 to the 4th times P to the 4th. 2 to the 4th, 2 times 2 times 2 times 2 is going to give you 16 times P to the 4th. Then for our final answer, we write that without the multiplier between it to show that it's multiplying, just because when we have a variable, we don't need to have that. So your final answer should look like this, 16P to the 4th. Okay, let's do C together. So we have the X, and then we have, we have the Y to the 2. So that 5 is going to apply to X and to Y to the 2. So when we rewrite this, we're going to rewrite it as X to the 5th times, and then in parentheses, we have Y to the 2 to the 5th on the outside. Remembering that if something in here has an exponent, put it in parentheses when you rewrite it and you break it apart, because then you can put your any-outie setup. So then we have X to the 5th times Y to the 2 times 5. X to the 5th times Y, what is 2 times 5? It's 10. And then we rewrite one last time without any multipliers between them. And that's our final answer, is X to the 5th, Y to the 10th. And again, the reason we have this in parentheses, if there's something with an exponent in here, put it in parentheses so that then when you apply the outside parenthesis, you have any-outie and you do your multiplying that we've done before. So D is really similar. Okay, so go ahead and do D on your own. We'll pause the video and then we'll come back and do it together. Okay, so in this one we have the 5, and then we have the X to the 3. 2 is being applied to both of them. So we have 5 to the 2 times X to the 3 in parentheses to the 2 on the outside. 5 to the 2 is 5 times 5, which is 25, times X to the 3 times 2. 25 times X to the 6. 25 X to the 6, written without a multiplier, is our final answer. All right, when you are ready, go ahead and flip your paper over and we will do the back. Okay, so just like every time we've done anything with negatives, you have to be really careful where you put the negative and if there's a negative being multiplied multiple times or not when we're using exponents. Remember, when the negative is on the inside of the parentheses, it stays on the inside. When it's on the outside, it stays on the outside. So this is going to kind of walk us through that again with the exponent being applied to multiple things. So if I have negative 3a, and my negative is on the inside of the parentheses, all to the power of 4, then that means that I really have -3 in parentheses to the power of 4 because that was my piece number 1. And my piece number 2 is the a, with my 4 being applied to both things. So I have a to the 4th here. If I have -3 to the 4th and it's in parentheses, it's like that, -3 times -3 times -3 times -3. I'm going to end up with a positive number, right? And my positive number is going to be 81, a to the 4th. Okay? Because I had a negative times a negative and I got a positive answer. Then I times it by another negative and I got a negative. Then I times it by another negative and I got a positive. So in the end, I end up with a positive answer because there are 4 of them. And it's that same rule where if there's an even number of them, you're going to have a positive answer. If it's on the outside, like this one, you can think of it as this -1 that just kind of hangs out in the front of your problem. So they just rewrote it with a -1 in the front to show you that. And you can just leave it there, and your answer is going to end up being negative because at the end, you're going to multiply it by that -1. So the 4 applies to the 3, and the 4 applies to the a. So you have that -1 times 3 to the 4th times a to the 4th, which ends up being -1 times 81 times a to the 4th, and you end up with -81 a to the 4th. Okay, so if the negative is floating on the outside, your answer is going to be negative. If the negative is floating on the inside, it stays on the inside, and it will depend on how many your exponent is as to whether it ends up being positive or negative. Okay. This next example, we're doing some of these fraction ones. So find the area of a square with a side length of x over 4. So x over 4, we're going to put in instead of this s, and then we're going to say x to the 4 to the 2. Okay, so that's the part you really need to worry about is the x to the 4 to the 2. So I have the top and I have the bottom. The 2 is going to apply to both the top and the bottom, just like we wrote on the front for that rule. So this is going to be x to the 2 over 4 to the 2, because I have written them with their exponent on both of them. X to this 2 stays as an x to the 2, right? But 4 to this 2 is just 4 times 4, which is 16. So then the answer just becomes x to the 2 over 16. Okay, so it's the same kind of process. Exponent applies to the top and the bottom, and then you kind of solve down from that. All right, let's look at the quick checks. So we have -2y to the 4th. So that -2 is on the inside, so that -2 is one object, and the y is the other, and the 4 is going to apply to both of them. So that means the -2 stays in parentheses to the 4th times y to the 4th. -2 in parentheses to the 4th, -2 times -2 times -2 times -2 is going to give me a positive 16 times my y to the 4th, and I end up with 16y to the 4th as my final answer. Okay. B, you can do on your own and will be pretty straightforward. C, I want you to do on your own as well, but I want to look at the pieces really quick together. So notice this has 3 pieces. So it has a -5, it has a to the 2, and it has a b. You're going to do it the exact same way. The 3 is going to apply to all of the pieces. Okay, so you're just going to have 3 pieces instead of 2, but you do it the exact same way. So go ahead and try B and C on your own with the video paused, and then we'll go over the answers. Okay, so for B, we have that negative on the outside. So remember, we just write that as a -1 hanging out on the front. We have a 2, and we have a y in here. Oops. So the 4 applies to the 2 and the y. So we say times 2 to the 4th times y to the 4th. So this is really -1 times 2 to the 4th. 2 times 2 times 2 times 2 is 16, times y to the 4th. Negative 1 times 16 gets me a negative 16 times y to the fourth. Negative 16 y to the fourth is my final answer. Okay, so it was the same as this one, but remember, inside the parentheses, outside the parentheses, changes how you set it up versus this, and then it changes your answer. All right, let's see how we did on C. So, negative 5 is in the parentheses, so negative 5 stays in parentheses to the third, times a to the 2 goes in parentheses because it has an exponent on the inside, all to the power of 3, times b to the power of 3. Beautiful. Okay, negative 5 times negative 5 times negative 5 is going to give us a negative 125 because there were 3 of those negatives, so you're going to end up with a negative answer. Then you have times a to the 2 times 3, right? Because it's an innie-outie, so you multiply, times b to the 3. Negative 125 times a to the 2 times 3 is really a to the 6 times b to the 3. And then we're going to write our final answer without those multipliers, b to the 3. So negative 125 a to the 6 b to the 3 is your final answer. So it's the exact same way we've been doing it. There were just 3 pieces instead of 2. All right, let's do A together. So we have a 1 on the top, and we have a 2 on the bottom. The 3 is going to get applied to both pieces. So we end up with 1 to the third over 2 to the third. 1 to the third is really 1. 2 to the third is really 2 times 2 times 2, which is 8. So our final answer is 8. Okay. You're going to go ahead and do B on your own. Just make that negative be up with the 2. Remember that it's inside the parentheses while you're solving this. Pause the video, and we'll come back together in a second to do them. Okay, so you had negative 2, and you had a 3. The 4 applies to both of those. So you end up with negative 2 to the 4 on the top, 3 to the 4 on the bottom. Negative 2 to the 4 is negative 2 times negative 2 times negative 2 times negative 2, which is just 16. 3 to the 4th is 3 times 3 times 3 times 3, which is just 81. And that is your final answer. Okay, I want you to try C on your own, but this kind of combines both types. So on the top, you have a 2, and you have an x to the 2, and then on the bottom, you have a 3. So that 3 is going to get applied to all of these pieces in a fraction form. So on the top, you're going to have similar to the other problems, and then on the bottom, you'll just have 3 to the 3. So go ahead and try C on your own, pause the video, and then we'll come back and go over the answer together. Okay, so the way we're going to write this, we're going to have 2 to the 3 times x to the 2 on the inside to the 3 on the outside. That's the top of our fraction. All of that is over 3 to the 3. 2 to the 3 is 2 times 2 times 2, which is 8. Times x to the 2 times 3 is the top of our fraction. 3 times 3 times 3 is 27, so that's the bottom of our fraction. Then you're going to have 8 times x to the 6 over 27, which really is just 8x to the 6 over 27. All right, that wraps up the video for lesson 5-9, where we are looking at powers of products and quotients.